Good evening, friends. Today we will learn the proof of Pythagoras theorem. A lot of teachers don't touch this in school, right? But this is very important. This proof is very important and very beautiful proof. So let us learn this. Pythagoras theorem, we all know what is it? The square of hypotenuse is equal to sum of squares of the sides. For example, if this is C and this is B and this is A, what does this say? C square is equal to A square plus B square. This is what we have to prove, right? And some elementary things that we know, that is area of a right angle triangle or area of any triangle is half BH, base into height, and area of a square is equal to A square. A is the side. Sum of angles of a triangle is 180 degrees, and two triangles are congruent if they satisfy any of this criteria. Side, side, side. If all three sides are equal, then the two triangles are same. Two sides are equal and one angle is equal, then also the two triangles are exactly same, that is congruent. Or two angles are equal and one side is equal, then also the two triangles are congruent. These are the basic things that we already know, and we will use only this to prove Pythagoras theorem. Why c square is equal to a square plus b square. Okay, the proof is a beautiful proof. What we do, let us start. Let us take this triangle A, B, C, and A and B are the legs and C is the hypotenuse. What we will do, we will construct a square with side C on this triangle, right? The side C, then this is also side C, this is also C. We'll construct a square C, 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 C. Let us construct a square first. Okay. Now square means this angle is also right angle. This angle is right angle. This angle is right angle. This angle is right angle. Right? Between this angle is right angle and this is also right angle. This is right angle and this is right angle. Right? This is the square. Good. Now let us draw parallel lines from the points of the square to which are parallel to the sides of the triangle. For example, let us draw a line parallel from B like this. Line parallel like this, which is parallel to AC. This BFI, this line, which is passing through B and this is parallel to AC. Right. Similarly, a line passing through A, which is parallel to BC. This line is BC, and we'll draw a line which is parallel to BC like this. Similarly, through E, we will draw a line which is parallel to BC. Alright, something like this. Like this. And through D, we will draw a line which is parallel to again AC. Right. So this line BI and this line are parallel. Similarly, this line, this line, and this line. These three are parallel. Right. Let us draw three parallel lines and they will meet somewhere like this. Right. All four parallel lines we have drawn 1, 2, 3, 4. All four parallel lines will meet somewhere like this. Okay. Now what we'll do, now a structure is formed. 1, 2, 3, 4, 5. 5 parts of this square. Right. There are 5 parts. 1, 2, 3, 4, and 5. 5 is the pink one or red one. Right. Now let us try to compare these parts. Let us compare this part BFA, ABF, and this part ABC, A B and C. This part, these two. If you try, this is also a triangle, this is also a triangle. One side is common, right? C is common, so one side is common. This is parallel. These two are parallel, right? These two are parallel and these two are parallel. What does that mean? This entire piece is a rectangle. And this entire piece is a rectangle. That means what? BF is equal to AC. BF this part is equal to AC. and this part is equal to this part, right? So this line is equal to this line is equal to this line. What does that mean? This triangle AFB, this triangle is congruent to ABC, right? This triangle and this triangle are same, basically. What does that mean? This side BF is equal to BF is equal to B, and AF is equal to A, right? Now we establish this triangle and this triangle are exactly same. What we will do now, let us look at the angles. This angle, this is B, this angle is B, and because this is a rectangle, right? If this is B, and because this is a rectangle, this part is 90 minus B, right? And because this is a right angle and this is a right angle triangle, this angle is also 90 minus B. This angle is also A is equal to 90 minus B, right? A is equal to 90 minus A plus B plus C. A plus B plus C is equal to 180. C is already 90. So A plus B is equal to 180 minus C, which is 90. If this is B, then A is 90 minus B, right? A is 90 minus B. If this is 90 minus B, what does that mean? This is A. This is A. And this is A, and this is 90 degrees. 90 degrees. And what does this mean? This is 90 minus A, then that means this is B, right? This is a rectangle, and if this is B, then this becomes A. Because this is also A, this is also 90 minus B. This becomes A, then this becomes B, this is 90 degrees. And again, this part is again a right angle. Right? This part. This part is also a right angle. This part is a right angle. What does that mean? If this becomes A, this part becomes B. If this becomes B, because this is a right angle triangle, this becomes A. If this becomes A, this becomes B. If this becomes B, this becomes A. If this becomes A, this becomes B. If this becomes B, this becomes A. Right? And this part, these four are right angles. Because we have drawn parallel lines. Right? These are right angles. Because we have drawn parallel lines to this one and this one, which are at right angles. That's why these four angles are right angles, and and this one, if this is B, this becomes C, and next angle will become B, and this becomes C likewise. Okay, hope you understood this. Because it is right angle triangle, if one angle is something, the other angle is 90 minus something, and we are using here the right angles of the square to identify that angles are actually the same. Now, at the same time, two angles are same in this one, two, three, four, these four triangles. At the same time, the side is also same in all these four triangles. Two angles, one side, right? As per ASA property, two angles on one side, this triangle, one, two, three, four, all four are equal. Right, all four are equal, and we already established this is equal to this. That means what? This triangle is equal to the original triangle. Original triangle is equal to 1, 2, 3, 4. 1, triangle 1 is equal to triangle 2 is equal to triangle 3 is equal to triangle 4 equal to triangle given. It's actually congruent. Congruent. All four triangles are exactly same as the given triangle. Right. Now there is a small piece of area that is left. What is this one? What is this one? Let's try to understand. I'll erase all of this again. Okay. Now, as you can see, this triangle, I have just drawn the figures again. This and this we already noticed. This triangle. This triangle is actually like this. If you rotate a bit, then it will actually overlap with this one. Similarly, this one. This one is this. If you rotate a bit, backward rotation of 90 degrees, let's say, then also this will overlap with this one. Similarly, this and this are exactly in the same orientation, and these two also will overlap. We already established all four triangles are same. This one, when we have already figured out two angles are same, right? If this is B, then this is A, and this is B again, and this is A. What does that mean? This entire this line is actually length is A. Right. What does that mean? BI is equal to A. Right? BI is equal to A. This part from here to here. And BF is equal to B. Right? Because all the triangles are same. All the triangles are same. So if this is B, A, B, C. Right. Similarly, this one will become C. This B, this is A. Similarly, this is B, this is A, this is C. All triangles are equal that we have already established. Right. Now, because we have already established, what we can clearly see this part. What is this part? This part BI is equal to A. Right. And BF is equal to B. What does that mean? FI is equal to B minus A. Right. Similarly, EH. What is EH? EH is again A. Fi is equal to, sorry, A minus B, right? A minus B. BI is equal to A, BF is equal to B, Fi is then B minus A. Similarly, EH is equal to A and EI is equal to B, then IH is also equal to A minus B. IH is also equal to A minus B. And these four are anyway, these four lines are parallel. Two sides we have established, both are A minus B. What does that mean? IFGH. This part is actually square. We have just established this. These are at right angles and two of the sides are same. What does that mean? FGHI. This part is actually a square. And what is the side of the square? Side of the square is A minus B. What does that mean? Now this is a square and there are four triangles. All four triangles are same. Now, what is the total area of the square? The total area of the square is square area of side C is C square. C square is equal to area of 1, 2, 3, 4. Let's say these figures 1, 2, 3, 4, and this 5. This plus 5. Right? Area of all of these parts. Part 1, part 2, part 3, part 4, part 5. Now, 1, 2, 3, 4, these are equal to the given triangle itself. Given triangle area is what? Half into base into h, which is half AB. Half AB into 4 times. This is sum of all of this. 1, 2, 3, 4. Plus fifth one. What is the fifth one? Fifth one we just discussed. This is a square and the side is A minus B. Side is A minus B and the area is A minus B square. Now what is this? 4 into half AB, which is equal to 2AB plus A square plus B square minus 2AB. Right, A minus B whole square, right? What does that mean? is equal to this 2ab, this 2ab will get cancelled. A square plus b square. What is this? This is equal to this c square. C square is the original area, right? Area of the square. This area of the square is equal to area of four triangles. All four triangles are same and equal to our original triangle plus a small square. That square whose side is actually b minus a. Which, what does that mean? A minus b, sorry. A minus, what does that mean? The length of the side of the square is equal to the difference between the length of sides of the or the legs of the right angle triangle. A minus b. A is the longer one, b is the shorter one. A minus b. This is the difference between difference. This difference is the side of the square. Okay. What does that mean? The square is actually broken down into four triangles which are exactly congruent to our given triangle plus one small square whose side is the the difference of the legs of the right angle triangle. Right. Now, when you equal the area of the total square is c square because c is the hypotenuse of this right angle triangle. At the same time, c is the side of this square. So c square is equal to 4 times area of this triangle, half AB plus area of this small square, which is a minus b whole square. Right. So that's how we arrive at c square is equal to a square plus b square. Now, if you notice, if given a square whose side is equal to hypotenuse of a right angle triangle, what is the number of triangles or number of similar or congruent right angle triangles you can cut from the square? It is actually 4. You can cut like this. What is the maximum number? It is 4. Right. Now, if both the sides are equal, A and B, if this is was an isosceles right angle triangle, then the square will become this square will actually become a dot because the diagonals will actually intersect at the same point. Now, because there is a square that is getting formed, and if the sides are equal, then there is no wastage, right? Then also four congruent angles you can cut from the square. This is the way to cut four triangles from the square, right? So this is an important corollary or derivation or extension of this problem, and you can expect that this problem also in exams, right? How many right angle triangles whose hypotenuse is the same as the side of the square can be cut from the square? We can actually cut 4 like this. Okay, cool guys, hope you understood this. This is There are various ways of proving Pythagoras theorem. This is one of the ways. We'll discuss another way in some other class, in another class. Thank you, guys. All the best.